Thank you, and it's a pleasure to be here. Let me start off by saying uh, I loved Francisco's gorilla. I thought that was a brilliant um, idea to do that and test that, which leads very nicely and segues into what I'll talk about, which is medical intelligence. So, most of you develop devices that measure something. A lot of you are developing these tools to supplement what physicians could do to measure things, to diagnose, et cetera. I want to challenge you all to say that if you're developing a device and it doesn't integrate some type of intelligence, you're contributing to the problem. The problem is the data tsunami, because we have so many devices today. We have so many things that are generating data. We have a tsunami of data coming at us, and we don't know what it means. And the physicians looking at it are missing Francisco's gorilla. So how do we solve that? How do we take a device that's creating a problem and make it part of the solution? Well, let's take a step back and talk about how medicine is practiced in general. Evidence-based medicine, the stuff we could see, the understood, the known knowns, are what medicine is based on. All this data becomes data exhaust. We're not collecting it. I want to posit something here. I want to posit the fact that if you actually look at that data, if you try to use it for diagnosis, interpretation, personalization of treatments, that is called intelligence-based medicine. And the little taste that we've gotten from using genomic data to position cancer drugs, to using integrated image analysis to look at cardiology, has taught us that there is this submerged part of the iceberg. There's a massive amount of intelligence in being able to diagnose diseases, to individualize treatments, and that's what I want to focus on, because I think that's going to be revolutionary. So if you're just generating something that generates data, it's creating too much data. We need to start thinking about translating that data into something useful. And there's really two approaches today that you can think of. Expert systems, and these are software systems based on what humans do, and they use very simple analytics, and a lot of you have integrated some analytics into your devices. The more systems you apply, the more knowledge you can translate. So the relationship between how much knowledge you can produce from data is directly linearly proportional to the amount of time you have to process that data. And recently, there's been this thing called machine learning, cognitive computing. You've heard a little bit about it with IBM, and some of these other companies have come up with it. It started off not being as good as expert systems. Now it's approximating expert systems. This is going to change. This is going to change everything, because the power of machine learning is not linear. It's exponential. The ability for a machine to autonomously learn from data and get better at learning has a power effect. And that power effect, that exponential, is quite noticeable over time. So everything you are doing today in terms of software analytics is going to be obsolete in just a few years, right? I've got 2025 there as a prediction. Already we know that it's going to come a lot sooner than that. We've already crossed over as of right now. We have machines that can create better software autonomously than coders can. So this future is here. Coming back to Francisco's gorilla, it's not just data, it's not just the streaming data from devices, it's also image data. It's also decision support systems. Everything is going to improve with machine learning. So we're prototyping something really interesting. So we started to say, well, how do we embrace that future? How do we embody machine learning into a healthcare environment? And we got these partners to come together. It's an effort led by Innovation Institute and CHOC, bringing in technology partners, including Systems Imagination, which I'm involved with, Intel and Dell, and started to think about knowledge networks of disease. Let's create a way that we can hierarchically represent knowledge. and extract data from knowledge. We have some history of doing this with genomic data. So this is a hypergraph where we've been able to take multiple patients, induce a subgraph of knowledge based on the whole genome. A whole genome has about 3 billion base pairs. So suffice it to say that you can create a machine, put in a human genome, and extract drugs that are relevant for that patient with no human intervention. So no human bias, et cetera. Now, I want to be clear, we're not trying to do man versus machine. So when you saw IBM and Watson, and that famous case where Watson beat a Jeopardy champion, that man versus machine is not the direction that we're going into. We're going to use technologies like this to make data more manageable for humans. So here's another technology, Saffron. Saffron is a company that was acquired by Intel, and it's one of the graph representation systems that we're using in the cloud to support this type of interpretation. So the idea of man versus machine is for Hollywood. In medicine, what we're really doing is we're taking this big data, we're processing it with machines, but then we're using human and expert interpreters as well. And what we're doing is we're amplifying the intelligence of humans. Rather than man versus machine, it's man and machine. And ultimately, the ones that benefit are doctors like Dr. Anthony Chang here, who's my colleague at Chalk Children's Hospital. He's the principal investigator on this particular project called the Medical Intelligence Cloud, and he's a cardiologist. He wants to process echocardiograms, EKGs, genomic data, device streaming data from devices, and he wants all of that processed with machine learning so he could make a better interpretation. So he could predict chemotherapy-induced cardiomyopathy from data and have a more differential diagnosis than he could possibly do without the data. So one of the biggest challenges is, of course, not just the streaming data that comes from devices, but also genomic data and integrating that genomic data with other types of biology. So this is where, in this particular project, Systems Imagination has come in. And so I won't go through this other than to say there are software analysis pipelines. Each of these vertical swim lanes is a processing of data to translate that data into knowledge. So from left to right, you can see that there are medical records, image data, pathology, and then various molecular analyses, including DNA, RNA, protein. All of those have a specific software analysis pipeline. Those pipelines produce features. Those features are fed into knowledge bases that are integrated and mined using machine learning, and the output of that is knowledge, insights that could be used by physicians and experts together to come up with better treatments. So I'll leave it there and just suggest to you that doing this, what we learned is this is really straightforward to do, and unless you're integrating some intelligence, some machine learning into your devices, you're not going to be part of the solution. So if anybody's interested in this, happy to talk more about that later.
Thank you, Spyro.